Okay, welcome back. Our next topic is electrical systems. How do you model an electrical system? And before we begin, we need to look at the basic building block of an electrical systems. And when we are building our circuits, we are either going to have inductors, resistors, capacitors, or maybe operational amplifiers, etc., etc. But for now, we are going to look at the basic elements of our electrical systems. And in terms of our inductors, for example, if you have, we have our current going in, and let's say this is IT, and we can look at a voltage drop across our inductor. Let's call this VT. Now, in terms of time domain, the voltage drop across the inductor, the voltage drop, usually it's written VL, so that you can say, okay, the L is for the inductor. It's equal to L di dt. And the frequency domain of this, all we do is we take the Laplace transform of it, and the Laplace transform of this is Vs is equal to L S I S. And our next component is the resistor, and let's assume that we have our current going in there. The voltage drop across our resistor is VR. Then the time domain of this will be VR is equal to R times IT. Okay, so it's just the current times the resistance, and the frequency domain will be VRS is equal to R times big I of S. Okay, and our last component is the capacitor, and with capacitor, assuming that our current is going in through there, and we have a voltage drop across this capacitor, and we can say that our voltage drop VC is equal to 1 over C integral I dt, and the Laplace transform of that is your Vc of S is equal to 1 over S times I of S. Okay, and it is very, very important as well to remember that when it comes to capacitor, sometimes you would want to write the information in terms of the current, because now we looked at the capacitor in terms of voltages, but if you want to look at it in terms of current, again, I'm just busy with the capacitor. We know that charge is equal to CV, and we know that if you differentiate this, you are going to have dq dt is equal to C dV dt, whereby the flow of electrical charge per unit of time, we can have it, we know that, I'm just going to write this, that we know that I is equal to dq dt, and So we can have the current voltage relationship for a capacitor, whereby we can just say that I is equal to C times dV dt. We're going to look at a very simple circuit so that we'll see how we use these components to get what is required.